Hi and welcome back to today's lecture. It's going to be about modeling strategy and best practice. So the following lectures will be both some PowerPoint slides, and also I'm going to do some hands-on CATIA modeling and programming. And the goal is to create a aircraft configurator and then automating a lot of repetitive design. So in order to really come up with good solutions, you really need to think about these three things, and that's why we're going to dive into them a little bit more today. So tool is something which helps you to do a particular activity. Method is how to do that particular activity, and the resource is a good resource is if you're good at using that tool because you're applying it with a good method. In this context, the tool is CATIA V5. Method is hopefully what we're teaching in F-TMKT57, and you will hopefully become a really good resource when you learn what we have to teach. All right. So let's say that the goal is to put some beams together. What is the best tool? And yeah, this is some kind of a trick question, mostly because by now you've probably figured out that maybe the power tool is not the most effective or the best tool. And I would say that it actually depends on the method. So depending on the resource, the hammer could be the best tool, or the power tool could be the best tool. What do I mean? If you're not a skilled carpenter, then you should definitely use the power tool, because the methods for how to use a power tool is not that hard. However, if you're going to use a hammer and nail, you need to apply a specific type of force and direction for the nail to get a very bent form while in the beams. That makes it very difficult to disconnect the beams. So if you have a resource who has this method, then of course hammer is the best tool. So if we start with the Miura, this was the first car that Lamborghini did, and it came out really great. And what is the fantastic thing about this car is that it is designed by a very young team with no prior experience of designing cars. So it's quite amazing that they could do this without doing any type of complex simulation of any sort. So how did they succeed? A very young team succeeded into designing such a fantastic car. The tools that they had was very elementary, and the method that they had was quite basic as well. So it was based on experience. The design was based on experience, and the validation was made by physical testing, and the communication was just physical communication. The key of success in engineering, whether it was 50 years ago or now, is fast iterations. So if you can increase the number of iterations that you do and you decrease the lead time, then there is a good chance that you will get a really good product in the end. Because the first iteration you will do will not be good. Not the second or third either. And as many iterations as you do, the better the design gets. And this is where they succeeded. Basically, their method was, if we do a change in the design, we'll take it out to the test track, we test it and see how it works. By being able to do this fast test, they were able to get a great product in the end. Forward 50 years. So as you know, complexity in every way has increased. When it comes to requirement, design tools, engineers, the organization has exploded. And although we have computer capacity which is off the charts and it keeps growing, it doesn't mean that design lead time has decreased. On the contrary, we have a very complex engineering today with different tools and disciplines and teams and divisions trying to cooperate. The resources, our engineers are spread out in a large organization, complex organization. The tools are also very complex. You need dedicated engineers in order to work with these complex tools. And the methods are a lot. Let's say like that. The methods are a lot. You have a lot of things going on. So in design, you have both like this experience base that was 50 years ago, but you also have like analytical and physics-based design, and then you have like tons of different virtual tools that you can use in engineering. In validation, same things there. You have like physical testing as you had before, and you have like many different type of physical testing that you can do. But then you also have virtual testing, which is also quite time consuming. Communication is physical communication as it was before, but you have also many different type of digital ways of communicating. And in my experience, what has made this all more complex than it should be is that people do the same work in different platforms. So it's not enough just to say, to convey an information to your colleague just by talking to that colleague. You need to also send them the mail. You need to also send a file through different mediums. So it becomes a lot of do-overs basically, and this takes time. The problem that we are facing is that design is very repetitive, and the tools that we have and the complexity that they come with and the resources who are not trained enough, this causes a big problem for the organizations. So, I mean, when you're working with a tool, for example, with CATIA V5, you're thinking like, okay, so this is a very powerful and complex tool, so this should be able to solve a lot of problems for me. And for most cases that is true, but first and foremost, you really need to understand how this tool works. You need to be accustomed to the tool. You need to work with all aspects of the tool. This is something which we try to do in this course. But then before you make up your mind that this is the tool that needs to be utilized for a specific problem, you also need to understand the problem. So maybe for a specific problem, you don't even need to use such a powerful tool such as CATIA V5. So think about the hammer and the power tool again. So just because the power tool is a more advanced type of tool doesn't mean that it always needs to be the best tool. And the same thing applies for many of the engineering problems that we have. So let's put this in practice. So we have a challenge, and that's going to be this aircraft configurator that I will model. And then also I challenge you who are watching this to also follow the procedures that I am giving out in this presentation. So in this case, we want to focus on how to make a flexible CAD model. And then you have to think about that this model can require a lot of changes. Your boss may want to change the design a lot of times during this product development process. So what we need to think about, if we were doing a robust and flexible CAD model, what are the 10 first essential CAD operations that we need to do? And here you need to think about point, line, plane, circle, pad, and each of these are one iteration. So what operation is the most important to do first? I could say that there are a lot of right ways of doing this. It is. But there's also a lot of wrong ways of doing this. Okay? So take your time, pause the video here, and try to write down on a piece of paper what ways would you choose to make the first 10 operations if you were going to design this aircraft. What are your 10 first essential operations? Okay, so lessons learned is if you used pen and paper, then you made the best choice instead of using CAD, because you can do more iterations when you use pen and paper, and that's the ultimate goal for success in engineering, to increase number of iterations. And with pen and paper you can do much more iterations than you can do with CAD. So congratulations if you use pen and paper. If you realize that the design that you did was not that great, I think it's very important that you recognize that fact and accept that you didn't do a good design, and try to learn from that. And that's the best way for you to go forward. And also, just a reminder again that it's definitely not about the tool, it's not about what advanced tool that you're using. It depends on the resources, the methods applied, and that is the difference between a successful engineering and unsuccessful engineering. It's about the methods that it's applied by the resources. Okay, so also I have a couple of slides when it comes to CATIA best practice. If you want to know what way is the best in terms of creating a certain geometry, it's always the easiest way and the simplest way that is the best way. That is also an engineering lesson. Don't complicate things just for the heck of it. If you can solve it in a simplified way, that is the best way. There are a lot of CAD functions that are unstable to use when it comes to design automation. Sketch is one of them. The Sketch tool is not very stable, definitely not for beginners that you can encounter. So we don't encourage you to use Sketch. Use wireframes in generative shape design instead. Same thing when it comes to the type of references that you use. If you are a beginner in design automation, then always choose references that are shown in the tree. So use the references that are presented in the tree. External parameters is a very unstable functionality in CATIA. Nobody uses it. I don't know why it's still there, but it's very unstable. Please do not use it. Measure tool, do not use it for design automation. There are scripted measure tools that you can use. There are some template code that are uploaded on LESAM that you can look into. Also hybrid design, as I've mentioned before, do not use it. Alright, so for the next lecture we're going to do more design automation stuff and visual basics. And hopefully by that lecture you have also looked into the Power Copy tutorial. Thank you and see you on the next clip.